Welcome to another puzzle time with MoMath and MathPickle. Today you're going to have to imagine the fancy screen that we have to say welcome everybody. And here we go, because it's not looking a very exciting screen at all. In fact, it is so boring looking. It is all one color and it is all gray. Yay. Okay. Yay. I knew you'd appreciate that avocado cream. And yes. So today, let me just grab you guys here. Good. Okay, so today is a mini mathematical universe. Hello, Nathan. And like all mini mathematical universes, you wake up one day and you find yourself in a strange universe. And whenever you get to be the scientist, you can either poke and I will tell you what's going on, or you can take a guess. And if you take a guess and you're wrong, you're going to lose a point for everybody. You're all on the same team here. You're all trying to figure out the rules for this universe. If you guess and you're right, then you gain a point for everybody. So I'm going to start with Solly. Do you want to guess what's coming up next, or do you want to poke and I will tell you what's coming up next? You probably have no idea what's coming up. So you're muted now. So yeah, you can unmute.
I'm gonna poke right here.
Yeah, I'm just going to tell you what happens. So what happens whenever you poke is that I tell you that number one, the answer is 1. Let's go with Super Kitty Cat. Tell me what happens whenever, or do you want to poke for 2, or do you want me to tell you what happens?
I'm...
You can poke like a scientist, or you can guess, try to figure out what I'm going to do next, but that's dangerous.
I'm going to do the same thing that Solly did, and I'm going to poke.
Okay, there we go.
I can't poke.
Number 2, the answer is a 2. Solly, can you remove that dot? And Oscar, I'm going to ask you for number 3. Do you want to guess what's going to happen? Or do you want
I want to guess that it's a 4.
You want to guess it's a 4? Oh, no, it's another 2. You guys are at -1 point. Oh, my goodness. So I'm writing down -1. Okay, and next it is Nathan's turn. Nathan, do you want to guess what happens next?
I'm going to be a bold man here, and I'm going to go guess. So
you're going to guess? And what are you going to guess?
What would I guess? I'm going to guess. Is it 3 yet?
Is it 3? And let's see. It's 2 again. We are at -2 points. You guys are at -2 points. Oh my goodness. Annika, it is your choice. You can either guess what's going on in this universe, or you can poke and be safe. And you don't lose points, but you don't gain points. What would you like to do, Annika?
I'm going to poke for 2.
But no, poking means I will tell you the answer.
Oh.
You don't have any danger.
Guess for 2.
You're going to guess for 2? And it is 2.707.
Oh, that's interesting.
We are down to -3 points. -3 points. I think it's a record of -3 points by the 5th
It could be at -5.
The 0.707 count.
That it counts. I don't know what this universe is. Okay, Taco Cat, you are up. Taco Cat, what do you want to do for 6? Do you want to guess, or do you want to poke? And I will tell you the answer.
Are we talking about... No, we're not talking about square roots. I thought for a moment we were talking about square roots. Well, I think 6 will be less than 3, but more than 2.707.
Okay, so
I'm
is
not
that
logic in Nathan's guess yet?
Okay, so this is a formal guess then, between 2.07, more than 2.707, but less than 3. Okay, if you're right, then I'll give you a point. How about that? You want that? Okay, here we go. And
Yeah.
are we right? And oh, we are wrong again. We are down to -4 points. We are suffering here. Seth, do you want to poke like a scientist, or do you want to be crazy like everybody else who knows nothing about this universe, but who's pretending they know everything? Do you want to poke, or do you want to guess?
I am going to poke.
Yeah, speak up, Seth. I can hardly hear you.
I am going to poke.
You're going to poke, and I'm telling you the answer is 3. Ruta, it is your choice. What do you want to do? Do you want to poke, the safe thing to do, and you're just poking around trying to figure out what's going on? Or do you want to guess?
I'm gonna say 3.
You're going to say 3? And Ruta is the first person to actually make a point.
Yay.
Yes, we are.
Negative.
You have taken this sorry bunch from a -4 to a -3, Ruta. So you got that was great. Daniel Hodgins, you are up. This includes adults. Go ahead, Daniel. What do you want to do here? Do you want to guess, or do you want to poke?
I'm guessing it's less than 4.
Less than 4? You have to be a bit more specific. Like if you said less than 100, well, that's not really
Okay.
worth the point.
Greater than 3, less than 4.
Greater than 3, less than 4. Okay, I will give you a point if you're right. And oh, you are wrong. And we're back to -4 again. All of the progress made by Ruta is lost again. We are down to -4. We are now up to Tin Can. Tin Can, do you want to be safe? Do you want to not follow the example of most of your peers here? Do you want to be safe and to guess and to poke here? And I'll tell you the answer. Or do you want to go crazy like everybody else and make a prediction?
I want to poke.
You want to poke? I will tell you the answer. It is 3.707. Okay, number 11 is 3.877. Avocado cream, you're up. Go ahead. Tell me what you think for 2. Do you want to poke, or do you want to guess?
Poke.
Poke. Okay. The answer is 4. Okay. Oscar, it's your turn.
I guess 4.
4. And you get another point. You have taken us from
Yay.
-4 all the way up to -3.
So high.
Yeah, so high. Gabriella, for adults too, what do you think? Do you want to poke, or do you want to guess at what's coming up in this universe that you find yourself in?
I guess 4.
And you're right. And we are now up to -2. We have not been so high for a long time. Okay. Next.
I think I'm starting to see a pattern.
Okay. Tell me about your pattern.
Well, we had 1 1, then we
Yeah.
had a group of 3 2s,
Yeah.
then we had a decimal,
Yeah.
then we had a group of 4 3s,
Yeah.
we had 2 decimals, and now we're starting to have 4. So I think we're going to have 5 4s.
5 4s. Okay. There we go. We're going to have 4 and 4, and this is 2 formal guesses, 4 and 4, and we have now got up to 0 points. After all of that time, we are back to 0. Back to 0. Annika, it is your turn. What
I'm
do you want to poke?
4.707.
4.707. Here we go. We have a strong guess, and 4.675. We're back to -1. Oh no, we're back to -1 again. Okay, Nathan, it is your turn. What do you want to do? Do you want to poke, or do you want to?
I'm a poker now.
You're going
I'm
to
gonna
poke.
play the poker now.
4.822.
Nobody could have guessed that, could they?
Well, maybe, but I don't know.
It's
Maybe
really lucky to maybe.
it
but-
would have been very lucky to guess
We're
that.
probably not those lucky people, so I played it safe.
Yeah, I didn't say this was a kind universe. This is a particularly nasty universe. This is the nastiest universe I've made, I think. Yes. Okay, so Nathan, actually we'll jump to Steve. Steve, do you want to poke here, and or do you want to take a guess?
I found
guess
Taco Cat's
5.
reasoning very attractive about the sequence and the 5 4s and the 1 2 decimals. So I'm gonna guess a range higher than the last one and lower than 5.
And you got a point. Yep, you got a point. So you guys are now up to 0 again. Solly, it's your turn.
Okay, +7 +3.
So what do you think for, this is 20 now, for 20, what do you think? So we have some calculations going on here. Is that distracting, or is that okay? Can we leave
No,
those?
That's fine.
I actually want. I say greater than this one, smaller than 5.
Greater than this one, smaller than 5.
No
And
scribbling.
yeah, no scribbling, thank you. And oh no, it is a 5. So we are down to -1 again. Oh, oscillating back and forth between positives and negatives. Ethan, it's your turn. I know, Ethan, you don't have a clue what's going on, but neither does anybody else, because this is a mini mathematical universe. You have woken up, and this is what you wake up to. And you have to figure out the rules for this universe. And so far, you guys are proudly standing at -1 points. You get a point every time you guess a correct answer, Ethan. You lose a point every time you guess a wrong answer. And if you just want to poke, then you don't lose or gain any points. And I'll just tell you the answer. It's never an embarrassment to poke, because poking is what scientists do all the time. Ethan, what do you want to guess? Now we're now at 21. What would you like to guess for 21, or do you want to poke?
What? What do you mean?
Okay, so you can just follow along for a while, because I know you came pretty late. Taco Cat, what are you saying? You're saying 5 5 5 5 5 5. All these 5s. Let's go 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 go. And we made 1 2 3 4 5 points. Oh no, this one you got wrong, but this one you got right.
Oh,
okay.
I miscalculated. I meant to have instead. I only marked off 5.
Okay, miscalculations are still a loss. So that is
No,
+4
I
minus.
thought there were 2 5s there.
Okay. It's a poll time, and then we'll get back to this mini mathematical universe. Okay, let's stop sharing, and we can go on. So, yeah, you're up 5 points. So now we are at +4 points, and we've got 1 2 3 4. Okay, so let's see. So, tell me, Nathan. Tell me about what you think of Taco Cat's idea.
It's pretty neat, in fact. I
Okay.
think that there's 3 2s, 4 3s, 5 4s, and now 6 5s, so 7 6s.
Okay.
I think it's the 7 6s. Let's see if we're right.
Okay. And Ruta, are you happy with this?
Yes.
Okay, here we go. 1 6 2 6 3 4 5 6 7 6s, 7 6s. You guys have got it. So now you're at +11 points right now. You have never been basking in the sun so happily. And let's see. Now we're going to go with the points. So yeah, you guys understand part of this universe, certainly. do you feel like you have a really solid feel for everything that's going on in this universe? Are you really confident or just partially confident? Seth, how confident are you about your real knowledge of this?
At the theory. Oh, sorry, I'm unmuted.
Seth, how confident are you that you understand this universe really well? Or do you think you understand parts of it? Partially confident? Yeah.
I think that we understand the general idea of the universe. We understand basically everything except for what the decimals will be.
Yeah. So now I'm going to show you guys this universe in detail. So you guys have done your work now. Now it's time for you to sit back and I will show you how this universe was constructed. So you can remove all of the squiggles, and here we go. A single square. Here are two squares inside a larger square. The larger square has a 2 by 2 square. And I'm just going to do that. Okay. And I'm just going to do this and clear. Okay. Next, here is for, oh, there we go. Let's stop that. Okay, for 3, here we have 3 squares. They fit in a 2 by 2 square. Here we have 4 squares fitting in a 2 by 2 square. So there we go. What do you think is going to happen for 5? Well, there's 5 squares in a 3 by 3 square. But if you remember, the answer to 5 was actually not 3, was it? Okay, it wasn't. It was 2.707. So where does that come from? It's not 3. Here's the answer. This is the answer to 5 squares being packed into a larger square of edge length 2.707. Okay, that's the smallest square that you can fit 5 little squares into. What about for 6? Well, for 6, it has to be 3, and let's see if that's true. Yep, there we have 6, 7, 8, and 9. Now 10, can you imagine what 10 might look like? Think about it for 3 seconds. And here's what 10 looks like.
Oh no, it's not satisfying at all.
Not satisfying. It's beautiful. Look at this. This edge length is 3.707. Okay. And
it's not beautiful. It's not beautiful.
oh, it's stunningly beautiful.
It's
Ethan.
ugly.
Well, it's your universe. You don't get to choose. Ethan, go ahead.
No, like I can tell, like if you put, I could already see there's like 3 squares. Like you could fit 3 more squares split apart into different shapes in the black parts.
Oh yeah, if you cut squares apart, but if you're not allowed to, and in our universe, you're not allowed to cut the squares. You have to fit them into your suitcase. You can imagine you're going off for holiday with a whole bunch of little square cookies, and you have to fit them in your suitcase. Well, you'd need to buy for 10. You would need to buy a suitcase of dimensions 3.707, blah 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 blah.
I have a question.
Okay.
Why don't you just eat some and then go happily off?
No. You want to save up cookies like for several years before you eat them. Don't they become better with age? I think so. Okay, so there's the answer for 10. For 11, let's see if you guys can figure out for 11 what it looks like. And of course we can't figure it out because it's really hard. It's something that would take years probably to calculate. And we don't even know if this is the best possible answer, I don't believe. So 3.877. There we go. Pretty hard one to guess. 12, 13, 14, 15, 16, 17. Are you ready to guess what 17 might look like? Here is 17. totally crazy. Like, how would you guess that you needed to buy a suitcase of size 4.675 in order to hold 17 cookies, square cookies? Yes, difficult.
Wow.
Here's 18.
That's still unsatisfying.
Well, at least it holds your cookies. This is 19 coming up. There's 19 and 20, 21, 22, 23, 24, 25, and 26.
Ew.
27.
That's
That's
a little
actually
bit
kind of
better.
satisfying. This one's kind of satisfying.
Okay.
That one's okay.
Okay. So we have a pass. So you can go out and buy a suitcase that's dimensions 5.707 to hold your 27 cookies, and you'll be happy. 28. Also
That's kinda cool.
That
satisfying.
one's very satisfying.
Very satisfying. Absolutely. Very satisfying.
Really cool.
29,
Really
do you think it'll be nice and regular like this? This is why I love this, is because 29 is totally bonkers again.
Ew.
Like you have those nice, like I'm happy if you say ooh to this one, because look at this. It's terribly nasty looking.
Yeah.
30.
30
There,
looks
now-
fine. 30 is
Yeah,
fine.
now you're happy. Now you're happy. And 31, you're happy. And 32, and 33, 34, 35, 36, and 37. Do you think you're going to be happy?
Not really.
Not really. There you go. You're
Not at
definitely
all.
not happy. Yeah.
That looks wrong. I don't know. I feel like this
38.
should be
This looks
math.
good. This looks kind of
This
good.
one's another one of those satisfying ones. I think the next one's going to be very satisfying.
Very satisfying. There. Are you satisfied,
Ah.
Seth?
Yes, this one's very satisfying.
Really
Very
bad.
satisfying. Okay.
No,
And 40.
Oh, this one's
This
very
one's-
satisfying. This one's
this is
extremely
cool.
satisfying.
Finished. That was
Extremely
the sneeze
satisfying.
to indicate that we are finished this mini mathematical universe. And we're going on to the next one. There we go. So these mini mathematical
His mother
universes,
had
these mini mathematical universes were inspired by Robert Abbott, who published in the Scientific American in 1959 a game called Eleusis, and also by Sid Saxon, who published in 1969 a game called Patterns 2 in Scientific American. And these two games were pivotal in me wanting to design mini mathematical universes.
What's
Okay,
this?
it is time for a new and much more nasty. So this mini mathematical universe, I will tell you right now, this mini mathematical universe depends on you guys being familiar with factorization. So I hope that you know what the factors of a number are. If you don't, I'll just give you a brief rundown. The factors of the number 18 are all of those numbers that you can divide 18 into equally. So for example, 18 divided by 2 would be 9, because you can have two sets of 9. So that would be one factor. Another factor of 18 would be 3, because you could divide 18 by 3 and end up with 3 sixes. So those are factors of a number. So you need to know that before going ahead. So I hope that you guys are all at that level. Okay, so I've started you off here. I've told you that behind A is the number 2, and only the number 2. And I will also say that this mini mathematical universe goes on forever in this direction. Yeah, it goes on forever in this direction. So I have just to make it easy to fit on a slide, I've said A, B, C, D, E, F, G, H, I, J, K, L, but really it should be A, B, C, D, E, F, G, H, I, all the way across, and keep on going forever. Okay, so just so you know that there's nothing special about the rows. We are going to jump in with, we're going to go with Tin Can. Tin Can, would you like to poke at B, or would you like to guess what's behind B?
Poke.
Poke. Okay, here we go. I'm going to tell you what's behind it. The first thing that's behind it is this.
What?
Yeah, there you go. It's a pattern. And I'm going to guess that you want to poke again. So we're going to poke again at this. I'm going to tell you the integers that go into here. So you have a 4 and 2 2s.
Oh, that makes sense.
Okay, perfect sense. Perfect sense. Okay. Ethan, tell me about this. C, would you like to poke like a scientist, or would you like to guess like the crazy people in this room who tend to guess
Yes, I'm
even when they know nothing?
guessing the top is probably no wait, can I first watch somebody else do this and then we can,
Sure.
okay.
Oh, for sure. Super Kitty Cat, go ahead and tell me what you want to do here. Do you want to poke like a scientist and I'll tell you the answer, or do you want to guess?
I'm gonna guess it's 8.
8. Okay, let's see. And you were right. You got a point for your team. And that has got to be one of the great guesses in human history in many mathematical universes. Super Kitty Cat. From such a minimal data set, you figured out that there's an 8 there. Nathan, it is your turn. Nathan, what would you want to do here? What kind of pattern?
Well, that we have 2 and 4 and 8.
Yeah.
So my guess is that it's going to be 16.
16.
Powers of 2.
Oh my goodness.
Yay.
You're at +1. You guys are now at +2. Holy
2
Moses.
points.
Solly, it is your turn. Solly, what would you like to do? Say it again.
32.
32, and let's see. Here we go. You ready? 20. Oh no, you guys are back to 1.
20.
It's a 20. It is a 20. It is not a 32.
Oh no,
I know
a beautiful
that
pattern.
Why is it 20?
Why is it 20? Oscar.
I noticed that always the first time a prime number appears, it's underlined, like the 2 and the 5.
Okay, there's a great hypothesis. We'll call that the Oscar underlining primes hypothesis. This is the Oscar underlying primes.
These are factors of the number. If you notice that 5, 4, and 2 are factors of 20. 2 is a factor of 4, and then 2 and 4 are factors of 8.
Okay. So I'm going to just get Annika. Annika, tell me what you would like to do with F. Would you like to poke it, or would you like to take a guess, Annika?
I think this time I would like to poke.
Poke. Okay, here we go. I'm going to show you that first, and I'm going to show you this second.
What?
This is a
It's
32.
Wasn't the 32 supposed to be where the 20 is?
But it's not. It's not. This is the mini mathematical universe.
I get it now. I think it's 16 plus 4 equals 20, and 20 plus 8 equals 30. I mean, 20 plus something equals 32.
Okay. Okay. We've got the hypothesis that this is based on addition. So this is Ethan's addition hypothesis. So I'm going to write that down. Ethan's addition hypothesis. And can we have Seth? Can we have for G? You can do a single poke. You can do a double poke, whatever you want. I've been doing double pokes from now on. So I'm showing you both the structure and I'm showing you the number, but you can do a single poke if you want as well.
Okay, so I'm guessing that at a certain point in this puzzle, 64 will show up and 128 and so on. But
Okay.
for this one, I'm just going to poke because I'm unsure when they're going to show up.
I'll do
Can I do the next
poke.
one?
And I'm just going to say for Seth, that is Seth's power of 2s. 2s will appear hypothesis. Okay, so we've got 3 different hypotheses going here. We've got the Oscar underlining primes hypothesis. We've got the Ethan's addition hypothesis, and we've got Seth's powers of 2 hypothesis. Taco Cat, here is the structure that Seth has revealed. Do you want to poke, or would you like to try to guess what number?
Well, I've
you're gonna
noticed
poke?
that 16 is 2 times 8, and 32 is 2 times 16. But I'm not sure how the 20 fits in, so I'd rather poke.
Poke, okay. The answer is 40.
I thought so. I thought it would be.
Weird.
Okay. Ruta, go ahead, Ruta. Oh, is Ruta's friend there, by the way? Sometimes I know Ruta as a friend.
I just noticed
She's not here today.
Okay, okay. Ruta, go ahead. Tell me what you want to do with H. Do you want to poke? Do you want? I'll just poke at one at a time now.
I really don't have. I really don't have. I don't know what.
What the
any of
heck's
the
going
others
on?
could be. Yeah, I don't know. Oh,
Okay, so that is code for help me poke.
Yeah,
So,
pretty
yeah.
much.
Okay, I've got it. So we've got this here. Daniel Hodgins, do you want to poke, or would you like to guess what is going on here, this number?
Poke.
Poke, and it is a 64. So that it lends credence to Seth's powers of 2 hypothesis. Tin Can, do you want to poke, or do you want to take a guess at what's next?
Poke.
Poke, there we go. There is a poke. And Ethan, your turn. Do you want to guess what's in here, or do you want to poke? Do you want to guess the number at the top, or do you want to poke?
This isn't going to be 128. Let me see.
So Solly says this is not going to be 128.
Maybe 96.
96. Okay, I think this is a marvelous direction. It's a very composite number, and certainly the numbers that we are seeing here are very composite. So although this is a wild guess and it turns out to be incorrect, it's actually 72. Your guess of 96, Ethan, I think was a really good guess.
So now we've got the 3 underlined.
Yeah.
I just noticed something.
Say something like I also wanted to say something like, so 20 plus 12 equals 32, so that's like 3 4s, and like then it's 32 plus 40, that's 2 4s, that's minus a 4. But the 64, I don't get how it fits in.
Yeah, it's good to keep an open mind because it's complicated. Seth, you've got your hand up.
Okay, so I noticed that it's not that big of a discovery. I just found out that the bigger number is always on the right side, and if they're the same number, it doesn't really matter.
Okay, so for 16, they're the same number. So we'll call this the balanced number.
Yeah, so it's
balanced
either
numbers.
Yeah, they're either equal or the right side is larger.
Okay, so that's Seth's balanced number. Annika, you had a comment, I think.
I have a strategy that I think goes on with this.
Okay, go ahead,
2
Annika.
plus 2 equals 4. 4 plus 4 equals 8. 16 plus 16. Well, that doesn't equal anything, but I'm guessing that it goes back 2 to 4, and 16 plus 4 equals 20.
And it goes by parts of 2.
And then 20 plus 12 equals 32. 32 plus 8, again, it goes back 3 this time.
Uh-huh. And the 32 is kind of like 20 plus 8 plus 4 is equal to 32. So there seems to be something that's related to going backwards in the stepping. Is that what you're thinking?
Yeah. And
Okay.
then
Mhm.
40 plus 14 equals
24.
16.
Yeah, so the 20 plus the 4, maybe, or the 16 plus the 8.
Yeah.
Okay, so this is kind of honing in on Ethan's addition hypothesis. And yeah, really interesting. So 64 plus 8 is equal to 72. So maybe there's something there, but difficult to precisely figure out what it is. But yeah, there's maybe something there with Ethan's addition hypothesis.
I think I know what the numbers on the bottom are for.
Okay,
I think that the numbers at the bottom are for like when you multiply them, they equal the number on top. Like
2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. 9 times 72.
Yeah, that definitely looks interesting. So we'll call that Annika's multiplication from the bottom. Is that a good way to describe it, Annika?
Yeah.
Multiplication from the bottom equals the top hypothesis. Okay. Taco Cat, you are up. Do you want to poke at J, or do you want to guess what J is?
Poke.
Poke. I will show you the structure. I'll show you the structure, and then you can decide if you want to go ahead and guess. In fact, maybe we should all take 17.5 seconds and figure out what this number might be. So 17.5 seconds to try to figure out what this number might be. Okay, Taco Cat or Ruta, any ideas what this number would be?
I still don't know because I hear like a bunch of theories, and then like I hear that they're so different, and then like I don't know which one to choose. Like I don't know which one to follow because like
there's so many hypotheses here.
Yeah.
I have no idea.
I get
and
them
Taco
mixed
Cat
up.
doesn't know.
I get them mixed up in everything.
Okay. So here it is. We are poking and we get 88.
Weird. Very weird.
So let me just review. Oscar's underlying prime number hypothesis, the first time a prime number appears, it is underlined. This seems to be added in strength because we have the 3's first appearing here and they're both underlined. We have the 11 first appearing here and it's underlined. We don't have a 7 yet. Yeah, we don't have a 7 yet, but that's looking good for that. Seth's powers of 2, so far that's looking reasonable. Ethan's addition, and Annika also had something to do with addition. Annika's multiplication from the bottom. So this is 2 times 2 times 2 times 11 is indeed equal to 88. So this is holding. Okay, let's go back up to Super Kitty Cat. Super Kitty Cat, do you want to poke? Do you want to guess?
Poke.
Poke, there we go. There's a poke. And
weird.
Yeah, and do you want to guess now, or do you want to poke again, Ethan or Super Kitty Cat?
Poke.
Poke it is. It's 128.
Who would have guessed that?
Oh,
it's 40.
It's another power of 2. Let's go.
40.
It is another power of 2. So this is lending credence again to Seth's idea that all of the powers of 2 are somewhere in this infinite sequence of, I guess these are kind of ice cream cones that are upside down or something. Okay, L, let's go with Nathan. Nathan, are you there? I don't see, oh yes,
Yes,
you
I am. Okay.
Yes, Nathan, are you going to poke
okay.
or?
I really want to guess, but it's pretty hard to guess. I'll do one poke and then I'll see if I can guess. Oh, okay. This is tricky, you know?
The numbers have always been going up. They have never gone down.
So that is Solly's. The numbers are increasing hypothesis. So Solly's increasing number hypothesis. So yeah, we've got a lot of ideas.
I have another hypothesis.
Sorry, Nathan, it's your turn now. And yeah.
All right. I'm going to guess 160.
160, you have got it. You are now at +2.
Let's go.
You are now at +2. Now, was that a random choice, Nathan? Like, how on earth did you get that, Nathan?
I saw the structure and I saw that on the left side there could be I knew that it had to be like I was thinking about like multiples of 10, and I first started off with 130, but that would be 10 times 13, and 13 a prime number. So I tried thinking about what would happen if it was 140, but then now it's 10 times 14, and 14 can only be made up of 2 and 7, both prime numbers. So I thought, and I didn't think of 150, but I did think of 160. And I knew that the chart for 16 was on the right, so I had a feeling that it was it.
Right, because we've got the 16 up here, and it looks exactly the same, suspiciously the same as this pattern down here. Yeah, that was good detective work. Oscar, do you want to poke here, or do you want me to tell you the answer? Do you want to see the shape?
I want to double poke, but I
double poke. Okay, well, there's one poke, and I am refusing to double poke right away.
I'm wondering why 80 is not in the sequence, because there's 20, 40, and 160.
Wait, I have something.
80 is missing.
80 is missing. Yes, Solly.
16 times 4 is 64. 16 times 10 is 160. 8 times 5 is 40. 8 times something is probably 128. 4 times 8 is 32. 4 times 22 is 88. 2 times 10 is 20. 2 times
so
45.
lots of multiplication facts. Tying them together, difficult. Any ideas, Seth or Annika?
It's all in columns. It's all in columns.
Yeah. No, the columns are not really there. This is just one long horizontal line going this way. Yeah.
Notice that there's
so
always
2, 4, 8, 16, 20, 32, 40. Yeah.
I have another hypothesis.
Go ahead, Annika.
All of the answers have something to do with 8.
Something to do with 8. Okay. We'll call that the 8 hypothesis.
And another hypothesis is all in.
Can I say something?
Never mind. That has to do with columns.
Okay.
I noticed something.
So we're arriving at the end of today. So Ethan, you've got one last say, and then I have something to say.
Like, it's kind of weird, but like on the first file, like 2, 20, and 72, they all have 2, and in the fourth column, there's like 16, 64, 160. They all have 6.
Okay. But just so you know that there's really no columns here. This is just one long string, 2, 4, 8, 16, 20, 32, just so you know that. Okay, we're going to revisit this puzzle 1 week from today. So this is part 1, and we're going to have another mini mathematical universe session. We're going to finish off this one, and we're going to do, maybe I'll design a brand new one for next week. I'm not promising, but maybe. Okay, so take care, everyone, and keep this one in mind. And maybe I'll show you what this one is, just as you're leaving here. This last one is 176. It is 11 times 16. So that is my parting gift to you. Oh, no, I know what I'll do. As a gift, I will give you these 2 structures, but I won't tell you anything else. There we go. There, you get the structures to leave with. You can take a photograph of the screen if you want. But I'm not telling you anything else. Yeah.
So 2, 3.
Don't say anything this week, Seth. Seth, just you leave it, and if you want, you can email me if you have ideas. Okay. So take care, everyone. I will see you next week, same time, same place. Bye-bye.
Bye.
Bye-bye.
I have no idea what this is.
Yeah, this is, I think this is my best mini mathematical universe.
With the second one that you shown that you did not show the number, is it 260?
No, it's not.
Okay.
Yeah. But I really loved tonight. I thought that the number of hypotheses, I don't think that has ever been, I don't think that's ever been better here. So that was, that thrilled me. The number, like I've got like 10 hypotheses here and half of them are wrong, which is what I want. I don't want them all to be right. It means kids are being too cautious. So we've got crazy ones like the 8 hypothesis, like Ethan's amorphous addition hypothesis, and Annika trying to make it work.
Gord.
Yes.
I thought you dismissed that last column thing too quickly, because the columns do come up in the linear thing as multiples or residues, right?
Okay. So let's see.
So the left column is 1 mod 4 in position. The fourth column is 3 mod 4 or something like that. 4 mod 4.
So if it's a chance, that's interesting.
I'm just saying that the columns represent structure in the linear layout as well.
Mm-hmm.
Yeah, I know what this is. So
yeah.
But I think, and I don't think that's what the kid is thinking. But
no.
But in any case, it's interesting to allow some stuff like that.
Yeah.
Are you okay with spoiling it?
Sorry?
Are you okay with spoiling it? What do you think it is?
Oh, I'm not going to spoil it. If Gord wants to spoil it, he can do it.
Yeah, no. I if you want, I'm going to be here next week. Then I'll spoil it. Otherwise, I'll keep it a secret. I think it's my best mini mathematical universe, and it would be a shame to spoil it. And it's very useful pedagogically.
The kids came up with so many things, and they were so interesting.
Yeah.
I like these poke problems.
Yeah.
It gets them to talk a lot.
You know what started, one of the things that started it off is the totally ridiculous guesses for the first mini mathematical universe. We had Oscar guessing, like on the second thing, getting it wrong. Then we had another kid guessing and another kid guessing, like totally not trying to be smart to optimize their score, but it was just so much fun for all of the kids to just see their score going down and down and down and down. It just added a levity that I have never had before presenting a mini mathematical universe. So this was the best experience ever. And I have to find a way to replicate that. Just add to the goofiness for kids who want to guess. I just want to goof it up so that more kids guess. And so as the reward for guessing, even though their score goes down, they get this goofy kind of fun.
So maybe you can have confetti or some kid reward for every guess. That's some kind of celebration for a guess.
Yeah, that's exactly right.
Or you can have different celebrations. You can celebrate poking because that's what scientists do. You can celebrate guessing because you're taking a risk.
I want to make the poking, I think, a more somber. Yeah, congratulations. All scientists do poking. There's no embarrassment about that, to reassure them. But I think I want to have more kids making the perilous leap towards the emotional investment into a guess with the expectation.
Have it where where if they guess after, like, let's say the first 8 or 6 numbers, every guess would earn them a poke, where they
Yeah.
have to earn the pokes.
I think that we want the real score here is a distraction. It's a joyous distraction, but the real outcome measurement of success is engagement of the children, and engagement of the children in this case is linked to the ridiculousness of making a guess early on whenever they have no idea what's going on. And I have to celebrate that ridiculousness, and that's going to increase the engagement of the kids. And that happened thanks to the initial kids here who just went crazy. It was because of them that this was elevated from the more thinky time to something that just was fun, and the kids are all engaged and they're
Gord, I have an idea.
Yeah.
Getting something wrong should be celebrated. So perhaps you should simply celebrate guesses that are wrong.
That would be good, because you found something that isn't fitting a pattern you thought was true.
Right, but there's a lot of things about it's important to guess when you don't know, and being wrong is an important way of method of learning.
Yeah.
So
like you can, whenever I, for example, in a grade 2 classroom, and I'm giving a failure out to a child or children, I will talk about them being gooped. Okay, in this, what was the puzzle that got them gooped? It was the bubbling cauldrons. So, oh, you've been gooped, and that meant failure. But what child in grade 2 wouldn't like their teacher to say, oh, you've been gooped? Like, it's just fun. So we get hung up on what is success and failure, but for the child's emotional vibrational well-being, they want to be gooped. So they don't mind failing in front of the class whenever you call it something crazy and fun like that. So that's the type of thing that I'm going to look for going forward. It won't only be to celebrate one or the other, but it's just going to make the celebration, even though it can be really nasty, it's a tongue-in-cheek nastiness. So, yeah. Anyway, I loved this. This was one of my favorite puzzle time experiences yet. It showed new heights of what many mathematical universes are possible, or whenever they're done well. And I'm not taking credit for this. I'm giving credit to those initial crazy guesses that those kids made that showed me the right way to do this. I just have to make sure that that happens more often. So
I was the guess of 160 was inspired.
My gosh, Nathan was on fire after that.
The only ones that I thought of that I thought was right was 176, 88, 8, and 16. Everything else just confused me.
Well, you would be in the good company of many a mathematician.
Gord gave this talk to a bunch of mathematicians, and they were all quite challenged to make progress.
Yeah.
I remember the first one from the problem incubator.
Yeah.
Does anybody make any progress on the first one?
No, not beyond. And I
actually found a site that gives some of the years. Let's see if I can pull it back up.
Oh yeah, sorry, that should have been in there. It's Eric.
Yeah, Eric Friedman.
Friedman's Puzzle Palace. or packing palace. So yeah, usually I do have that link here.
So
I'm not able to send it to everyone, but here's
No.
the one I found.
Gord,
Yeah.
would it make sense? You're displaying stuff.
Oh,
So I got 220 is good. This is weird.
So would it make sense on the first mathematical universe to ask the kids, can they predict a bunch of numbers now, or explain why that theory was correct about the whole numbers, and they can work out when that happens, or to run with that a little bit.
yeah, I could have run with that a little bit. That's true. That's true. I could have.
And then the kid who figured that out gets a payoff, and other people will catch on.
Yeah, you mean to show, okay, so coming up to a square, for example, coming up to 36 at 35 and 34, there's no other way to pack it. It's just the obvious way. 33, obvious, 32, obvious. But whenever you drop down below 30, then it becomes, then there's a better way to pack it. And I'm not sure how exactly how I would do it. So I would have to think about that. As it was, I got the kids to figure out, or this universe I think is very good for getting the kids to understand, yeah, they can figure out part of the universe, but part of it is quite opaque. And that's okay. You guys have figured out, half of it maybe. And then this other part is just like totally confusing. But now let's look at the underlying structure of the universe. And then it just becomes, I find it just an aesthetic experience. And I love that avocado cream was making it, ooh, yuck. Like, I love that visceral response. That like she's committed to beauty. So that was just very special. So I don't know if I'm doing that one optimally.
Who knows?
Yeah, like what does optimal mean? But giving the first part of it, that they have to figure out part of this universe, and then the second part, oh, sit back, relax. Now I'm going to take you on a tour. I think that's a reasonable way to do it too. Yeah. But certainly I could push the connections more between, I could go back and forth more between the list of numbers and here's the solutions. Next number, solutions. So I could do that more. Yeah. Good. I am needing to go off. So
thanks so much,
everyone.
Gord and everybody.
Yeah. Cheers.
Bye.
Bye.